Hi, this is my first attempt to industrial conveyor belt. Let's get this thing on and see it running, but wait, it's very slow. How do I can speed this thing up? This is all about this video. I'll test 3 hardware and basically 3 code. This is my switching off on and off, and here is the connection direct to ULM 2003 board. This 4 vias is the controller. We are using Arduino Pro Mini. Let's see the first code in this test. I'm using 5 volts USB supply cable, half ampere. Here I am declaring the port B as stepper, configuring waiting time of 2 seconds. In the setup method, I put them all as output. In the loop method, simply fire 2 coins at the same time. This is called full step mode. See, we always fire 2 pins per phase. At 5 volts, we will get roughly 14 RPM. Let's check it out. But first, see this thing running again. Fine. The second option is Adafruit Motor Shield version 1. We are using 5 volts, half ampere power supply cable. Here is USB from computer, and these 2 chip are L293 DA driver DIP 60 pin IC. Oops, almost forgot. Always use this isolation right here in order to pass the test. The stepper must complete the lap 3 times at least in both directions. Then we put in a single direction and manually measure the RPM. In this connection, you can get it from Jungotronic, repeating. So in order to pass the test, the stepper must complete the lap 3 times at least in both directions. We are putting in a single direction and manually measure the RPM. Here we go. This is wave drive mode, where we find just a single phrase at a time. We put this initially to true in both directions with the shift speed of 350. We expect a 12 RPM. Let's check it out. The setup method, we configure the speed to the previous variables. Declare this chunk of code is for wave drive mode, firing just 1 coin. This is a full drive mode, firing double coil, half step, intermediate, and micro step is the quietest mode the motor can work. Let's turn the motor forward to measure the RPM, confirm the port, and run it. Now, one, two, 3, 4, 5. 6, 7, 8, 9, and 10 and a half, roughly 11 RPM. Now with 12 volts I expected 20 RPM. Let's confirm. Let's disconnect the power, change the volts to 12 volts half ampere, the speed of the shaft of the stepper motor to 700, and I expected 20 RPM. Let's see if this configuration passed the test. Oh. 1, 2, and 3. Passed the test. Let's turn the motor forward to measure RPM. Yeah. Now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Confirming 20 RPM, just fine. Now full drive mode, 500 as the speed of the shaft, and falls here. Through here and through here too. Let's see if this configuration passed the test. I expected, let's see, 50 RPM at 5 volts, 15. Let's run the code. One. Now. 1, 2, and 3. Passed the test. Now let's turn the motor forward to measure RPM. Run the code. Now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and a half, confirming roughly 15 RPM. Now let's see another mode. This is full drive, now 700 at 12 volts power supply, half ampere. Let's test it first. Now just rotate forward and backward. Let's see. 1, 2, and 3. Best the test. Now let's just rotate forward to measure the RPM. False here. Run the code. In the clock. Here we go. Now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 12 RPM. Confirm. 12 RPM. Confirm it. Yep, 12 RPM. Now another mode, half step. This is a combination of wave drive and full driving, stepping. Speed 400. Yeah, through here and through here to for 5 volts we are expecting 12 RPM. Let's prepare our plant. Yep. And let's upload this code. Done uploading. Okay. Let's see if it passed the test. No. Yep. Let's see. 3 times. 1. 360 degrees. 2. Yeah. And yep. And 3. Passed the test. Now just rotate forward. False here. Yep. Let's run. Run the code. Yeah. Let's see the clock. And now. One, 2, 3, 4. Oh my God. 5 and 6. Oh. And 7 and 8 and 9, please, 10 and 11. I expected 12, but I've got 11, roughly 12 RPM. Yep. Now, roughly, now we are gonna double the speed by supplying 12 volts DC. I put the speed to 1,000 and I expected 24 RPM. Let's run the code. Let's run the code. And whoa, look at this. All right. Hey, man. Let's see if passed the test. 1 and how 2. Yep. And 3 passed the test. All right. Passed the test. Now let's run it forward. False here. Run the code. And oh, let's see the clock. 24 RPM, remember? Let's see. Now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. Yep, up to 24 RPM. Now the last experiment with Adafruit board. Hold on, microstep. You will see that we will not have difference with the increase of 5 volts to 12 volts. Please observe this experiment. Hold on. Be with me. Take your time. This is important to know. Yep. Let's run the code. All right. The increase of 5 to 12 volts. Please observe. Pass it the test. Let's see. Now. Oh my gosh. One. Let's see. Please observe. 1, 2. Father. Oh my gosh. Yeah. Okay. It passed the test. We expected 10 RPM. Only 10. Let's see. False here. Run the code. Let's see. The clock. Oops. 10 RPM. Confirm. Let's see the clock now. Let's see. Yep. Now. Oh, 10. Only 10. 1. Oh my gosh. 2. And 3. Oh, and 4. 5. And 6 micro stepping. It's very slow. And 7. Oh my gosh. 8. And oh my gosh. 10, 9, and roughly 10 RPM. As I said, increasing to 12 volts has no gain in microstep mode. (11 RPM). Let's test it first. Change the power supply to 12 volts. Yep, that's it. As I said, increasing to 12 volts has no gain in microstep mode. Let's see. Now, testing. All right. Oh my gosh. 1 and 360 degrees. Remember, 2 and pass the test. Okay, let's run it forward to measure the RPM. We expected only 11 RPM. Not much. Microstep, the quietest motor. There is no sound. The clock. And let's see. Now. Okay. 1 microstepping. 2 microstepping. 3, 4, 5, 6, 7, 8, and 9. Oh my God. 10. We did all the experiments with Adafruit board, and now I present my main choice. This is the most efficient of all, the simplest and the fastest. See the fritzing circuit on my page on djangotronic.medium.com. Yep. L29 3D motor drive. It's awesome. 12-volt supply cable. And the code is available on my GitHub page. See link on my web page below. I drew a circuit of L29 3D motor drive deep 60-pin IC. The code simply makes the motor spin at 24 RPM without stopping. Yep, 24 RPM. Basically, the code simply sets up the 4 phases and fires them in a loop. See, phase 1, phase 2, phase 3, phase 4. All right. And in the loop, we call all these method Adafruit. I expected 24 RPM. Let's check it out. Yep. Let's see if it passed the test. 3 forward and backward. Let's see. Oh my God. Yep. Yep. Oops. Yeah. 4. Sorry. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. Yeah, 24. And that's it. Please visit my webpage. share, comment, interact. You will find the complete documentation of this experiment. Read the comments. This is the fritzing and the schemas. Everything was done with much effort and fondness. Yep, this is for you, especially written for you. Now see the experiment running and some constructive details that you can take advantage of for your project. Yep, this is L28AD board, beautifully the Arduino Uno, and I used colored pencils as axles. I used these Phillips screws M2 inside. Yep, this is the axles, the motor, 5 volts, and inside the pencil I use hot glue, a tape on the reverse, and thermal paper as belt. And that's it. Please check us out at Jungotronic at medium.com. This is your host, J3. Subscribe. Thanks for watching.